Okay, good afternoon, everyone. My name is Titaya Kukaew. I'm from Synchrotron University of Technology. The topic to present today is Synchrotron Based X-Ray Fluorescence technique to localize potassium and iron in cassava leaf. First of all, I would like to talk introduction, material and method, result and discussion, and the last conclusion. Let's move on to introduction. Cassava is one of the most economic crop of Thailand. The most cultivated area in the northeast of parts of Thailand. Many factors such as drought, cassava disease, and pests. Other important factors are soil malnutrition, sandy loam soil, and soil acidity, which negative affect plant growth and yield for a long period of time of nutrients. Are absorbed from soil to leaves, stem, and roots differentially according to plant and demand. Potassium is the highest amount of micronutrient, while iron is the highest of micronutrient. By cassava of a new cultivation, potassium and iron is critical for cassava productivity and quality because potassium plays an important role in moving nutrients from leaf to the storage root, and changing into the form of starch. Potassium deficiency in cassava can be absorbed from leaf symptoms. Typical symptoms include brown scorching and boring of leaf tip, as well as chlorosis. The olive iron is one of elemental composition of chlorophyll and involved in functioning of several enzymes. The primary symptom of iron deficiency is intentional corrosive of young leaves, but in severe case, the entire leaf turn yellow or white. The analysis of total nutrient in the leaf is used for evaluation of cassava, potassium, and iron status. For the chemical, by AAS technique has been a standard method for nutrient analysis in plant tissue. The method is time-consuming. Large amount of plant sample can be used to analyze by distribution of nutrients. Synchrotron White produced at the Siam White Laboratory is 1 million times more brighter than the light from the sun, can be used to study the atomic structure of various elements. It can be suitable wavelength or energy for use in the research. In this study at the beamlight 60, to detect trace elements in materials such as plant and soil. Now we're moving on to objective. The objective of this research were to study potassium and iron status, potassium and iron relationship between leaf, overshooting on leaf, and to study the possibility of using the FRF for potassium and iron analyzed in cassava leaf. Now, move on to the material and method. In the field experiment, cassava cultivar 89 were cultivated in sandy soil at the Synchrotron University Experimental Farm, Thailand. In May 2014, the experiment design was RCPD with purification to method of fertilizer application. Treatment 1 is control is no fertilizer. Treatment 2, NPK application, and the last, treatment 3, NPK and micronutrient. The amount of nutrient applied was based on soil analysis. All fertilizers were applied at the month after planting. For synchrotron analysis, at 4 months after planting the cassava leaf at number 7. position below the fully extended leaf were collected and cleaned and oven dry at 50 degrees Celsius for 48 hours. The work cut is the square here. Shape of the study area including the rim leaf, but and leaf vein, the elemental distribution of leaf were investigated by micro X-ray fluorescence technique. The analysis were conducted at the Beamlight 60 Synchrotron Light Research Institute in Thailand. The energy is ranging from 2 to 15 electron volt was focused by polycapillary half length, obtaining 30 multiplied 30 micro X-ray beam at simple precision. The single element vertex EM 600 and 50 silicon depth detector was used to count the CC camera, the selected area of Cassava leaf. The elemental distribute map were collected using 500 micrometer multiplied 500 micrometer pixel size with 50 seconds of X-ray exposure time per pixel. Used PyMCA software were used to analyze the XRF fluorescence data. For the chemical, AAS technique. At the same time of synchrotron analysis, the leaf sample were also analyzed for potassium and iron. With the chemical method, cassava leaf were oven dry at 70 degrees Celsius and digest using nitric acid and perchloric acid. Then potassium and iron into the digested sample were determined by the atomic absorption spectroscopy AAS. Here is the result and discussion. Leaf, potassium, and iron content. The application of micronutrient according to soil analysis could elevate potassium uptake by cassava up to the optimal level. Similar to chemical analysis, the XRF spectrum of potassium in cassava leaf of treatment 1 was lower than that of treatment 2 in the table 1. Yeah. The consistent result of both methods may imply that the XRF analysis could be used to determine the difference in potassium content of cassava leaf. For the chemical of iron table 1, it was found that iron content in table 2 was 108 milligram per kilogram within the range of efficiency. With real iron content in treatment 3 was 200 milligram per kilogram with the high range table in the table 2. This is the table 2 nutrient standard. Similar result was found in the XRF analysis. The spectrum of iron in cassava leaf on treatment 1 was lower than that of treatment 2 in the table 1. The both results confirm the XRF technique could be used to determine potassium and iron status in cassava. We have already looked at the leaf potassium and iron content, and now we are moving on to potassium and iron distribution on leaf. For potassium distribution, XRF technique can be used to evaluate nutrient distribution on various positions of the leaf. In the figure 1, show potassium distribution on cassava leaf determined by XRF technique. In potassium air treatment, figure 1D, here, The total count of potassium were consistently higher than those in control treatment. However, in both treatments, the variation of potassium content did not relate to leaf position and leaf vein. Compare 1B and 1A, 1B and 1C. On the figure 2, show iron distribution on cassava leaf determined by its RF technique similar to potassium. The total count and variation of iron in iron add treatment were greater than those in control treatment, and the variation of iron control did not relate to leaf position and leaf vein. One, 2A and 2B, and we compare with 2C and 2D. Sorry, this is figure 3. No relationship between iron and potassium content and leaf position in this study may be due to the leaf data of leaf sample were pre-measured leaf. The deficiency of iron and iron was not severe. Even the control treatment, there were no deficiency symptoms on the leaf sample. Usually, the deficiency symptom of potassium found in old leaf, while iron in the young leaf. Therefore, further investigation was performed on the leaf with severe deficiency symptom of potassium and iron in contrast. In control treatment, this is figure 3 is wrong. Show potassium iron distribution determined by FCT on cassava leaf with severe deficiency symptoms. It can be seen that the nutrient distribution tend to relate with leaf vein. Both nutrients were more concentrated around the leaf vein. The results suggest that the distribution of nutrients in cassava leaf with low nutrient status are different from normal leaf. Conclusion: the distribution of potassium and iron is pre-measured leaf has relationship with leaf position and leaf vein, and severe potassium and iron deficiency leaf, old and young leaf. The iron and potassium distribution tend to relate with leaf vein. And the last activity could be used to determine the nutrient status and nutrient distribution in cassava leaf. Thank you.
Okay, thank you, Titaya, for your great presentation. Okay, this is time for Q&A. Please, is there any question from the floor? Actually, this is also one of the advanced technique using synchrotron for the agriculture application. Please, anyone? Any comment, recommendation, question? Okay, Ms. Titaya.
Okay, I have one question.
Okay, please, Dr. Prapal.
Okay, since nobody asked, then I have something to ask. Can you go back to slide number 14? Slide number 14. 13 and 14. I see this result, K and FE,
yes.
Distributions. And so is there any correlation between each color?
Yes, the blue is a low energy. The red one is a very high energy.
High energy.
Yeah.
And
they can be detected ion of potassium and ion and
okay.
ion.
So what is interesting? It's the red one is the highest place,
yes.
where it's the highest energies, and the blue one's the lowest.
Yes.
But why the red one? Do you have any explanations why for the picture 3B, the red one it's at the bottom right
Yeah.
corners. Another one is seems to be in the center.
This next one.
Yes,
3.3
3.3 B. It's
yeah.
bottom right,
Yes.
but 3 D is at the center. Any explanations why the why it's like that?
Here,
Is there any trend to predict that the highest energy will be always around these locations, something like that?
Here is vein leaf. Vein leaf. You can see in the picture leaf. Before. Yeah. Leaf, vein leaf, and here is a severe potassium. Here is the severe iron. You can see here is the very low, very high, because the when elemental in the severe they will changing your to the young leaf, because this is the old leaf.
Old leaf. Oh, okay.
Yeah, they will changing into the trip, because here they will die. The leaf here is really high, because they will prepare to the trip leaf in the plant before they will die in the leaf die. But you can see here in the iron is the high in the symptom. Yeah, very high. It's around here the severe iron. They will in iron, they will severe in the tip leaf. Tip leaf is different potassium and iron position severe, because potassium in the old leaf and iron in the young leaf. In the young leaf, from the old leaf, they inflate through the tip leaf, because effect to charity, effect to plant growth in the plant growth, like that, something like that.
Okay, interesting. Okay, all right. Thank you.
Thank you.
Okay, is there any other question from the floor? So if no, I would like ask some question for you, Ms. Titaya. Yeah, this is very interesting. Actually, what is your consideration that you choose the K, potassium and iron, for your elemental analysis? As we know that the cassava leaf also contain many mineral, including zinc, mangan, magnesium, copper, calcium, phosphor, silicon, and etc. So why did you only focus on the potassium and the iron?
Because potassium is changing the start to the roots of cassava. Is very important in cassava. A different on another plant is in grape. Grape need more to put phosphorus, because about flower and fruit. Different plant and different elements important. I collect to potassium because the cassava is important about start, and in iron, because iron about inside in cassava very important in cassava, because about the changing the root, the start from leaf to the root is like a connect to the potassium and iron. I will choose the two elements.
Okay, so if you can count, as I know, SRF usually we can know the number, the percentage, but in your result you only show the image, the distribution. Is there no any number like the percentage of the mineral content? Yeah, I mean from your result. Yeah, you're only showing the distribution, the color distribution.
Yes, the mineral I will amount like amount of of plant, sorry, 15 kilogram per rice, like nutrient potassium need recommend from the
Yeah, I mean,
but if nutrient applied was based on soil analysis or fertilizer were applied, it's like a 15 NPK.
but in your manuscript, did you put that number? No. I mean, the number, the percentage number of the in your slide. I didn't see the percentage number, like how much the K, how much the Fe, iron. Only the distribution,
15,
right?
15 kilogram per rice,
Okay.
and
Okay.
15 kilogram per rice, and 15 kilogram per rice for the seed.
Oh, okay, okay, this one. Okay, okay. Okay, so you already show. Okay, good. Yes, good job. I think this is to emphasize the fertilizer or the content in the cassava leaf for the approachment, new approachment for the agriculture. Okay, is still any other question? We still have 3 more minutes up to 2 p.m. So if no, maybe thank you for Titaya. So please give a big applause for Titaya.
Thank you.
Thank you.